Good morning. In today's class, we'll see physical channels in LTE. Specifically, we'll try to see what is transport channels and their mapping to the physical channels. So before going into this, let us see the brief introduction to channels in LTE. So what do we mean by a channel? A channel is nothing but a medium where the information actually flows. The flow of information between different protocol layers. What the channel do? The function of a channel is to interpolate or combine or say segregate the different types of data and allow this combined data to be transported or transferred the information combined across different layers. Channels do have different types or say classification. This classification is based on two parameters. What are those two parameters? The first one is but the way they processes the information, that means how the channel is going to process the information based on this concept. And the next is kind of information they used to carry. Depending on these two parameters, we are going to classify the channels. Now let us see some typical types of channels. First one is say logical channels. What do you mean by saying a logical channel? The logical channel can be defined as the channel which concerns with what type of information is being transported. Next classification is transport channels. The transport channel main concern is to know how this information is transported or transferred. The next one is the physical channels. The physical channel mainly concerns with where to send this information. The figure below shows how different channels in logical channel, in transport channel and physical channels are mapped. In the earlier slide, we had seen this transport channels and their mapping to the physical channel. How actually the transport channel is being mapped to the physical channel. This same concept you can see it here. That is different types of logical channels. They are being mapped to transport channel. Then the transport channels, different types of transport channel. Let me name some few logical channels. PCCH, BCCH, BCCH say broadcast channel. So all these logical channels, multicast traffic channel, multicast control channel, dedicated traffic channel, all these different logical channels are being mapped to say a typical transport channel, say DLSCH, right? So this transport channel is then being mapped to the physical channel PDSCH. So now let us see about these few channels which are there in this figure. Say broadcast channel BCH. You are going to see transport channel. One type of transport channel is the BCH, that means broadcast channel. What is the function of broadcast channel? The function of broadcast channel is to transfer system parameters to the users. What are the system parameters? Say cell bandwidth, how much the that particular cell where the user is there, how much bandwidth is available, the number of transmit antenna. These two parameters information is being transferred to all the users using broadcast channel. Typically say downlink broadcast channel, DBCH. DBCH. So this is your BCH. DBCH means downlink broadcast channel. One more is say downlink shared channel. Downlink shared channel. DLSCH. Downlink shared channel. Different logical channels, say DTCH, BCCH and MCCH are being mapped to the transport channel called as DLSCH. So what is DLSCH? This DLSCH is nothing but stand for downlink shared channel. So what is the function of downlink shared channel? A downlink shared channel carries user's data. Whatever the data the user want to transfer to other user through the LTE system is being carried out by downlink shared channel. It do also transfer some control information. Next type of channel we want to study is paging channel, PCH. PCH, you can see it here, PCH. PCH falls into the transport channel. PCCH, logical channel being mapped to PCH. So what this PCH do? The PCH, as you can see, paging channel, it stands for carries paging information. What do you mean by saying paging information? Paging information is nothing but something like, suppose a person is sleeping and you want to awake that person. In the same way, when the mobile is into sleep mode condition, you want to awake it in order to receive information from the system. You are going to urgently send a SMS. So that short message carries information for the device, subscriber device, to get invoked, that instructing him that some information is being transferred from the system to it, so come out from the sleep mode condition. So this information is being transferred using paging channel. Next one is multicast channel. So this, let me tell you one more point. Paging channel actually, as I said, transfer the user from idle mode or sleep mode to connected mode, right? So RRC, radio resource control idle state, to radio resource control connected state. That means earlier the user or the subscriber device was in idle state or sleep mode state to connected state. Now the user is in, immediately gets waken up and it is ready to receive information from the system. Next is a multicast channel. Multicast channel used for transferring multicast content. That means one same information being transferred to some n number of users. So that particular user is among one of them. So it receives the same copy of information, something like xeroxing the same information. So that type of information is being transferred using multicast channel. Next one is uplink channel, MCH. You can see it here, MCH, it is there here. Multicast channel, it is one type of transport channel, right? So multicast channel next. So transport multicast information to the user or subscriber device. SD stands for subscriber device. Uplink shared channel. Uplink shared channel, random access channel. So these are nothing but the other types of channel. So this is nothing but a typical channel mapping we already seen once again. So now let us see in brief what are these logical channel types. As you have seen earlier, logical channel, you can see it here, different types of logical channel. All these are nothing but the different logical channels I am pinpointing. So what these logical channels are, different types of logical channels. Logical channel, what the logical channels used to do, type of information, MAC priority, user equipment identification. So traffic channel, so traffic channel used for sending user data, control channel used for sending signal information, radio resource control, right? So again here broadcast control channel, what the broadcast control channel do, controls and transfer system information. Paging channel, paging control channel, right? Paging control channel information, paging messages to, as we already studied, LTE idle state to connected state. So all these are nothing but the different types of logical channels, and they have been grouped in this fashion for easy understanding. So these are nothing but the different types of transport channels. As you can see it here, transport channel, MCH, DLSCH, BCH, PCH. So these are nothing but the transport channel. PCH, paging channel, carries paging information. BCH, broadcast channel, carries broadcast information, like this. So these are nothing but the different types of physical channels. So modulation, what type of modulation is being used? So we are actually using quadrature amplitude modulation. Say it is QPSK, quadrature phase shift keying. It is also being used QAM, QPSK. QPSK is one type of quadrature amplitude modulation only. There are actually two parameters that are being changed or exploited for carrying the user's information, say phase and amplitude. That's what is called as quadrature amplitude modulation. So QPSK is one derived part type of QAM. So why we are preferring QPSK in case of LTE? QPA being preferred because of good power transmission efficiency. There are again different derived types of QAM, that is quadrature amplitude modulation, say namely 16 QAM and 64 QAM. It is depending upon the number of bits being combined, 16 bit or say 64 bits, right? So present concern is not that one. You already seen this one in your earlier studies. So physical random access channel, physical random access channels, non-synchronized transmission in the uplink. So physical random access channel, non-synchronized, and they occurs frequently and provide sufficient information, sufficient number of random access to users for getting information for transferring. So physical random access channel, in short it is called as PRACH, physical random access channel. So depending upon this physical random access channel, we have got PRACH modulation. It is a type of phase modulation, sequence generated with phase difference between different symbols. So sequence is generated depending upon the phase difference, say pi by 4, 3 pi by 4, 4 pi by 4, 5 pi by 4, because it is quadrature. Depending upon the number of bits combined, say 2 bits combined, 3 bits combined, 4 bits combined, we are going to have the phase difference accordingly. So between two different consecutive symbol. So physical random access channel modulation takes into consideration the phase difference between different bits, pair of bits or 3 pair of bits being combined, and how much should be the phase difference. What I just said, you can see it here. Here I have combined 2 bits, say 00, 01, 10, 11. Say if it is a binary, you are going to have only 2 bits, say 0 and 1. And what are the different possible combinations? 0 0 0 1 1 0 and 1. Here it is a quadrature, 2 bits per symbol. You are going to combine 2 bits per symbol, right? And as per that we will be having the data rate as 2 bits per second. Here we are going to have 4 bits per symbol, 4 bits. As you can see it here, 4 bits are being combined, 4 bits are being combined. Accordingly you will be having it, you are going to call it as 16 QAM. 4 4 4 and 4 4 8 12 16 16 bit QAM. Similarly here you are going to have 4 bits per symbol combination. So all these 4 bits together represent a particular symbol, right? So you can see it here. Obviously if you combine more bits, you are going to have the data rate increase. Here only 2 bits being combined, 2 bits per second. 4 bits are being combined, you are going to have the data rate increases 4 bits per second, right? So similarly here you are going to have 64 QAM, right? So here 6 bits per second being combined, so that's why it is 64 QAM. So if you 2 to the power 6, it is 64, right? So accordingly it will be 6 bits per second. So depending upon the different number of bits combined, it is called as 64 QM, 16 QM, 64 QM, or say 2 QM. Now let us take one particular example, say 64 QM. If you combine more bits, you are going to see that accordingly the signal to noise ratio varies. So say this center is nothing but the source from where the signal is being transferring. So in this direction the signal is going to decrease in its quality or say strength. Decreasing signal quality, or that is also being called as fading. Fading is nothing but information gets weakened. So this is how the information gets weakened. So different types of channel being multiplexed, say BC broadcast channel, physical control channel, then those are being multiplexed to transport channel, then those channels being multiplexed to physical channel. So these we already seen this one in our earlier discussion. So this is all.